Shell and tube heat exchangers will look something like this. With this design, we normally find the inlet and the outlet for one fluid at the very end of the heat exchanger, known as the header. Then we have another inlet and outlet for fluid 2 on the main body, known as the shell. Inside the unit, we have the tubes. These bend and loop around to start and finish at the tube plate, which sits between the shell and the header. The tubes will usually also pass through some baffles, which are sheets of metal. We will see how these work in just a moment. The header, as well as the tubes, can be removed for cleaning, repairs, and maintenance. Inside the header is a sheet of metal known as the divider, or the partition. This separates the tube ends, enabling the fluid to flow into and then out of the heat exchanger tubes. Fluid 1 will flow through the header, into and around the tubes, then back to the header. Fluid 2 will enter the shell and surround the outside of the tubes. The baffles will partially block the flow, which will force the fluid to turn multiple times. This creates a turbulent flow and ensures that fluid 2 mixes with itself, which ensures maximum heat transfer. For example, we might find this in a pharmaceutical factory with a boiler providing steam into the shell, which surrounds the tubes. A chemical product is then pumped through the tubes, and this absorbs the heat of the steam through the tube wall. So this product is going to exit the heat exchanger much warmer. Meanwhile, the steam will start to condense into a liquid and flow back to the boiler to pick up more heat and repeat the cycle. Additionally, these are used in refrigeration applications, like this industrial chiller. We have the water flowing through the tubes and the hot refrigerant in the shell. The water will absorb the heat of the refrigerant so that it can transport this to the cooling tower, where it will be ejected into the atmosphere. The water returns cooler to pick up more unwanted thermal energy from the chiller. We have covered how chillers work in great detail previously. Do check those out. I'll leave a link for you in the video description down below. Double pipe or tube-in-tube type heat exchangers will look something like this. This is similar to the shell and tube heat exchanger because essentially we just have a tube which runs back and forth a number of times between an inlet and an outlet. This is surrounded by a shell which has another inlet and outlet. A metal frame will hold the unit in place. Typically, these will all be made from stainless steel. One fluid will flow through the tube and another will flow through the shell. The two fluids are separated by the tube wall and transfer thermal energy through this tube wall. The different configurations result in different temperature profiles and heat transfer. In this design, the bend at each end isn't utilized for heat transfer, and heat can be wasted here. However, manufacturing this heat exchanger is cheaper and obviously easier. Other designs like this hairpin type heat exchanger, which are often found in oil refineries, will encapsulate the bend to fully utilize the surface area for heat transfer. This version normally uses multiple tubes to maximize the surface area and thus increase the heat transfer, although this will also increase the resistance. These are a fairly simple heat exchanger design and are very common particularly in food processing as well as pharmaceutical production. For example, we might have a dairy product flowing through the tube, and then we have hot water or maybe even steam flowing in the opposite direction through the shell, which will warm the product up to a certain temperature before it is mixed with some other ingredients and then bottled. Check out one of these videos to continue learning about mechanical and thermal engineering, as this is the end of the video. Don't forget to follow us on Facebook, LinkedIn, Twitter, Instagram, TikTok, as well as theengineeringmindset.com.